Hello, organic chemists, and welcome to our next video lesson where I'm going to walk through another set of molecules to go ahead and name them for you. Today we're going to take a look at molecules that contain functional groups. These are groups that contain things other than simply carbons and hydrogens. So the level of complexity in terms of naming these is going to get a little bit harder compared to previous lessons. So let's jump right in with this first molecule here. So let's take this slow. We'll go step by step on these first few. Let's first identify the functional groups. Clearly, I have a couple of double bonds. So the term diene, D-I-E-N, is going to make an appearance in the name. Di for two, ene for the double bonds. And then this collection of atoms here on the right of the molecule, hopefully you should recognize that as a carboxylic acid. You should have the list of functional groups handy with you as I go through these sample problems so that you can see the priority of the different functional groups as well as simply the category of the different functional groups as I go through these samples. Okay, so let's go ahead and number the molecule first. So this is going to be carbon number 1 right here. That is part of the carboxylic acid functional group. Sometimes students get confused, but when we have these C double bond O fragments like this, the carbon that's part of that C double bond O fragment is typically going to be part of the parent chain. So we have carbon 1, and then I'm going to have 2 on carbon 3. I'm going to have the beginning of one of the double bonds, and on carbon 5, I'm going to have the beginning of the other double bond, and the whole molecule is 6 carbons long. Okay, so let's go ahead and work out the name of this fellow then. So we're going to have double bonds at the 3 and 5 positions. So I will have 3, 5. It's 6 carbons, so that's hex. And then I have to get in the fact that there are 2 double bonds. So it's hexadiene. And then I have the carboxylic acid, so it gets the OIC, oic, and then it's called acid. And this is one of the few names where there's a space in the name. So it's 3,5-hexadienoic acid. Now the 3 and the 5, as hopefully you recall, we can insert that in between the root name of the parent chain and the ending of the functional group. So I could also call this hexa 3,5 dienoic acid. So I can put that 3 and 5 right sort of in the middle of the name, okay? So remember, whenever you have double bonds or a functional group, the number that indicates its location can always go kind of at the beginning of the root name of the parent chain, or it can come after the root and before the suffix that indicates that kind of functional group. Now, I'm not going to be consistent about showing both alternatives all of the time, but I'll do them occasionally. All right, let's move on to the next problem. So again, let's go ahead and identify the functional groups. So now here, this fragment here, we have a C double bond O, an oxygen, and that is then singly bonded to some other carbons. So hopefully you can recognize this as the ester functional group. Excuse me. And then we also have an OH group. This is an alcohol functional group. So now we have a case of 2 functional groups that are on our big list of heteroatom functional groups. When that's the case, one of the functional groups, the one of higher priority, is going to be named using the suffix, and the other functional group, the one of lower priority, is going to be identified using its prefix. If you take a look at that list, esters are of higher priority than alcohols. So we're going to use the O8 ending for the ester, and we're going to use the hydroxy prefix for the alcohol. Now, esters can be a little bit tricky. Let's go ahead and do the numbering. Carbon number 1 of this molecule is going to be right here, the C of the C double bond O of the ester. And then we have 2, 3, 4, 5 at carbon 5 is where the alcohol resides, and it's overall a 6 carbon chain. So when you name esters, the first part of the ester you actually name is the part that's attached to the singly bonded oxygen. In this case, the portion that's off to the left. And so we're going to name that as a branch at the very beginning of the name. And then we take care of the rest of the molecule. So let's go ahead and start to name this. So for that branch off of the singly bonded oxygen, that's a 2-carbon branch. So that's going to get the ethyl branch name. Then again, I'm going to hit the space bar here. So esters are another functional group where we, again, rarely are using the space bar if we were typing out this answer. So there's a space, and then I have, at the 5 position, I have that alcohol, which we will use the hydroxy prefix. And then my main chain is 6 carbons long, hex. There's all single bonds, so it's ane. And then it gets the ester suffix of -08. So ethyl 5-hydroxyhexanoate is the full answer there. Next example here. Let's identify our functional groups. So we have a C double bond O. There's a lot of functional groups with C double bond O in them, aren't there? So we have C double bond O, and then on either side I have a continuing carbon chain. So this is a ketone with carbons on both sides. So we've seen carboxylic acids, esters, and now simply ketones. If one side, if say on this side here, instead of having 2 more carbons, if I just had a hydrogen, then that would have made it an aldehyde. We'll see an example of that a little later. So here's a ketone, and then over here, I have yet another C double bond O group, and with what looks like an amine group hanging off of it. But since that amine group is attached to the carbon of the C double bond O, that whole collection of atoms is a functional group, and it's called an amide. Amides are of higher priority than ketones, so the ketone here is going to get the prefix oxo, and the amide is going to get the suffix amide. All right, so let's go ahead and number the molecule. So carbon number 1 is that amide carbon. Then we have 2, 3 at carbon 4 is where the oxo ketone is going to be. And then I have 6 carbons total in my molecule. These first 3 examples, I've had 6 carbon parent chains, just a coincidence. All right, so let's go ahead and then do the full name. So at position number 4 is where that ketone shows up, so that gets the oxo prefix. And then I have a 6 carbon parent chain, all singly bonded, so it's hexane, and then I use the AMIDE suffix for the amide functional group. So we have 4-oxohexane amide. Sometimes people pronounce amide as amide. Both are acceptable. All right, next problem. Identify the functional groups here. So I have an NH2 group that's attached simply to a carbon. So this is an amine functional group. And then I have something we haven't seen yet. I have a multiple bond here involving carbon, but not oxygen this time, but nitrogen. So remember, there's a C right here. So I have a C triple bond fragment, okay? This is called a nitrile. Nitriles are of higher priority than amines, so I'm going to use the nitrile suffix and the amino prefix. Excuse me. So let's go ahead and number our carbons. So the carbon of the nitrile that's right here is going to be carbon number 1. Then at carbon 3, I have that amino functional group. At carbon 4, I have a methyl branch. Then we have 5, 6, 7 carbons long. Finally, I'm out of the 6 carbon parent chain trap I was just in. All right, so let's go ahead then and write out the full name of this molecule. We have 2 branches, the amino branch and the methyl branch, so I have to abide by alphabetical ordering. So this is going to be 3 amino, 4 methyl, and then I have 7 carbons, so that's hept. Everything's singly bonded, so that's ane. And then at carbon number 1, I have the nitrile. All right, so that's 3 amino, 4 methyl, heptane, 1 nitrile. Now, this 1 that I wrote in for modifying the location of the nitrile, again, that could be put outside here in front of the hept. So I could also call it 3 amino, 4 ethyl, 1 heptane nitrile. All right, would be another way to name that name that molecule. You could also probably get away without having the 1 at all, because the nitrile there is a pretty high priority functional group. So you might see some IUPAC suggestions that you don't need the 1 there. I always like to put the 1 just to make it really clear, because there's actually nothing terribly special about nitriles. They sometimes can be located on carbons that aren't carbon number 1. So I would put the 1. All right, moving on, let's take a look at this molecule here. So we have now some new functional groups. So as promised, here's that C double bond O with a hydrogen on one side, and I've overtly drawn the hydrogen. Imagine if you saw the bond come down here and then just the C double bond O and literally nothing else over there, right? You would have to know to assume that there's a hydrogen there, and that this would still be an aldehyde. But for simplicity's sake right now, I overtly drew in that hydrogen. So I have the aldehyde functional group, and then I have over here a carbon attached to an oxygen, then attached to another carbon. All right, so this is going to be an ether functional group. Okay, so the best way to handle this would be to use the sort of branching terminology for an ether. So when we have ether branches, you know how we have the YL ending for simple alkane branching. We have the OXY ending for branches involving ethers. So this is going to be referred to as a methoxy branch. There's 1 carbon, there's the oxygen. So this whole unit together is going to be called the methoxy branch. And then I'm going to use the AL suffix, the all ending, for the aldehyde. So then let's go ahead and number this compound. We have carbon number 1 here of the aldehyde. 2, 3, 4 is the location of the methoxy branch. And then I have 5 carbons overall in my chain. So let's write out the full name. We're going to have 4 METH for the 1 carbon in the ether branch, oxy, OXY, for the ending of that ether branch. Then it's a 5 carbon chain, so it's pent, and it's singly bonded, so it's AN. And then I use the AL ending for the aldehyde, so 4-methoxy pentanol. Now I could also overtly include a 1 here in between the pentane and the aldehyde, but aldehydes are kind of a special functional group. They are typically the beginning of the parent chain, and because there's only just hydrogen on the one side, they have to be located on carbon number 1. Now, it could be that they get combined with a much higher priority functional group, and in that case, you would want to put in the number. But here, I can kind of get away without putting the number. If you're ever confused if you should put the number 1, just put it in. I think that's the best practice. Always put the number location for all functional groups. Don't think, oh, this is on carbon number 1, so I don't need it. I would put it in. It's only for things like maybe carboxylic acids or esters that you can kind of get away without putting the 1, because those are very high priority functional groups, and 99% of the time they're going to begin the chain of the molecule. All right, let's look at one more example, and that is this fellow here. So this actually brings in the issue of having 2 fairly high priority functional groups. As we've seen before, I have this collection of atoms, which hopefully you now quickly recognize as the carboxylic acid, and then I have brought back the ester functional group as well. So if you look at our list of priority groups, you'll notice that the carboxylic acid is of higher priority than the ester. So I'm going to use an oic acid ending, and then I'm going to use this carbonyl prefix to designate the fact that I have an ester here, and then that I have this branch here. So the way that we use sort of the prefix terminology for esters is this group is going to get the oxy ending, and I'm going to refer to this whole group as a carbonyl, C-A-R-B-O-N-Y-L, or carbonyl, if you want to pronounce it that way. All right, so let's go ahead and number my molecule here. So let's see. I've got 1, 2, 3, 4. So we begin the numbering here, the C double bond O of the carboxylic acid. On carbon 2, I have a methyl branch. Then I have 3, 4, and that's going to be the end of my parent chain right there. This whole portion here is going to be treated as one unit when I identify the ester functional group there. So I have a 4-carbon chain. And so now the name of this is going to be, at carbon number 4, I have what we will call an ethoxy carbonyl group. All right, so that takes care of literally everything that I put in that red box. So it's ethoxy because there are 2 carbons there, and then the carbonyl or carbonyl terminology takes care of everything I just put in that blue box. And then at position number 2, I had a methyl group. And let's see, we have 4 carbons in my main chain. So then this is, butane because it's singly bonded. And then I use oic acid to finish off the name. Sorry, I had to squeeze it in there. So we have 4-ethoxycarbonyl 2-methyl butanoic acid. All right, so having molecules that have 2 very high priority functional groups is actually kind of rare. So this use of ethoxycarbonyl, for example, you're not going to see that a lot in common organic chemistry molecules, but I wanted to show you at least one example when you have 2 very high priority functional groups, how you handle the terminology there. Okay, so hopefully with these 6 solved problems, you're getting more comfortable with the nomenclature of molecules that have heteroatom functional groups. After this lesson, including the functional groups, that's pretty much going to be it for nomenclature. We're going to do a little bit more with alkenes for nomenclature things, but in terms of all this work about nomenclature, we're pretty much going to end it here. All right, hopefully that helps, and we'll talk to you next time.